Hi students. So we are solving the problem by transportation model. So in the last lecture we have solved the problem by the VAM method. Now we will check the problem for a modified distribution method, or it is called as a MODI method, or we will consider as a check for optimality. Now I will show you the problem that we have solved in the last lecture. So this is a problem we have solved. Find the initial basic feasible solution by oval approximation method. So this is a problem. I will provide the link of this last lecture in the description. You can check from there. So this is a problem, and here we got the allocations. Now we will solve the same problem by the modified distribution method. Means what? So in the previous problem we have got the initial basic feasible solution, that is 779 rupees. So this is a transportation cost for transporting the from one city to the another city. Now we are checking if we can reduce the cost, again reduce the transportation cost from this 779 to the some value. So for that we are using the check for optimality, and for that modified distribution method, or it is called as a MODI, MODI method. Okay. So before going for the MODI method, we have to check for the degeneracy. So we have to check for degeneracy. So degeneracy is nothing but we are checking the number of allocations. So for that there is a formula: m plus n minus 1 is equal to number of allocations or not. So here m are nothing but the number of rows. So here if you check, there is a 3 rows and there are the 4 columns. So 3 plus 4 7 minus 1, that is equal to 6. So I will write here 3 plus 4 minus 1, so 7 minus 1, that is equal to 6, is equal to, now here we have to check the number of allocations. So in this problem we have solved the problem. So we got the allocation. So these are the allocation. So 5, 2, 7, 2, 8, 10, these are the allocations. And if you check the number, so there are 6 numbers of allocation. So this is not a degeneracy problem, means we are having a formula m plus n minus 1 is equal to number of allocation. So 6 is equal to 6. So we can go for a modified distribution method or MODI method. So how to solve for the MODI method? So there are, again we are solving for the occupied cell and unoccupied cell. So first is for occupied cell. So what is occupied cell? Where at the cell there is a allocation. So here 19 is a cost and 5 is the allocation. So this is a, we can say, occupied cell. Here 10 and 2 is the allocation. This is occupied cell. So these are the occupied cells. So we know these 6 are the occupied cell. And for occupied cell there is some relation. So that is ui plus vj is equal to cij. So I will explain what is ui, vj and cij while solving the problem. So here u is nothing but it is used for a row, v that is for the column, and cij that is a cost associated with that cell, we can say. Suppose ui, so if I am giving the u1, so this is a u1 is nothing but the row number 1. So here u2 and u3, row number 2 and row number 3. Similarly v1, v2, v3 and v4. So these are the column. v1 is the first column, v2 is the second column, v3 is third column, and v4 is the fourth column. Similarly, the Cij is nothing but the cost. So here 19 is a cost, 30 is a cost, 50 is a cost, 10 is a cost. So these are the costs. So this is a relation for occupied cell. So we are solving first for occupied cell, and then we will solve for the unoccupied cell. So in unoccupied cell there is a relation is Cij minus ui minus vj. So this is a relation for the unoccupied cell. Now we know that Cij is cost, u is for row, and v is for the column. Now how to use this relation we will say in the next table, we can say. So here first we will calculate, we know this is a problem and initial basic feasible solution for this problem is 779. So again we want to reduce the transportation cost. So for that we are checking for the optimality. So before going for optimality we have to check for the degeneracy. So degeneracy, m plus n minus 1, number of allocation. So here m is number of rows, n is number of columns. So 3 plus 4, that is 7 minus 1, 6. So there must be the 6 allocation in the this matrix. So here already 6 allocations are there. If the allocations are less, then it is called as a degeneracy. So in the next lecture we will see the degeneracy type of problem. Okay. So here first case for occupied cell and second is for unoccupied cell, and relation is given here. So We will see for occupied cell. So here we are knowing the answer, or we can say this is our initial basic feasible solution. Now we will calculate for occupied cell. Now occupied cell, which are the occupied cell? So where there is allocation, these are the occupied cell. Now I will remove the other values here from here, so it will be easy to understand. So where there are the occupied cells, so here these are the occupied cell, these 6 cells are the occupied cell, and here initially I am giving the name u1, u2, u3, that is a row number u1. Similarly v1, v2, v3 and v4, these are the for the columns. Now for occupied cell we are having relation ui plus vj is equal to cij. So how it is? So I will write first what are the different occupied cells. So different occupied cells means here at this u1 v1 location there is allocation, or u1 v4 location there is allocation, or u2 v3 there is allocation. Similarly I will write first the occupied cell here. So first occupied cell is u1 v1, then u1 v4, then u2 v3, u2 v4, then u3 v2 and u3 v4. So these are the occupied cells. Now we are having the relation. Now relation is ui plus vj is equal to cij. So ui means what? This u1 row, and vj means this v1 column. And I will write and then I will tell you u1 plus v1 is equal to, so here ui plus vj is equal to cij. Cij is nothing but this cost is a 19. So u1 plus v1 is equal to 19. Similarly, second occupied cell here u1 v4. So there is a relation u1 plus v4 is equal to, the cost is here 10. Similarly u2 v3. So u2 plus v3 is equal to, cost is 40. Similarly u2 plus v4, the cost is 60. Then here u3 plus v2, cost is 8, and u3 plus v4, the cost is again here it is a 20. Okay. So this is for occupied cell relation. Now here initially we are assuming that any value, you can assume any value 0. Here I am assuming u1 is equal to 0. You can assume any value u2, u3, v1, v2, v3, v4. Any value you can assume a 0. So initially I am assuming this u1 is equal to 0. So this relation becomes, so 0 plus v1 is equal to 19. Okay. So 0 plus v1 is equal to 19 means, that means v1 is a 19. Okay. So v1 value we got to 19. So I will write v1 is a 19 here. Similarly now u1 is again, here it is 0 plus v4 is equal to 10, means we got the v4 is equal to 10. So v4 value we got, that is a v4, here I will write a 10. Now here we know now v1 and v4. So we will put where there is a v1 and v4. So here it is a v4. So I will put v4 value 10 here. So this relation become, I will use another color. So u2 plus v4 value is a 10 is equal to 60. If you solve this 10 going toward that side, and it will become u2 is equal to 60 minus 10. So that is a 50. So here we are getting u2 value 50. So I will write u2 is equal to 50 here. Now here we know u2 value. Now I will put u2 in the, here we got the u2 value 50. So I will put u2 plus v3 here 50. So this will become 50 plus v3 is equal to 40, or this relation become v3 is equal to 40 minus 50. So that will become a minus 10. So here we got v3 is equal to minus 10. So I will use v3 is equal to minus 10. Now I will put, we know that u2 is there, v3 is there. So v4 we know that is 10. So I will put v4 in the last equation. So here it will become u3 plus v4 value is a 10 is equal to 20. So if you solve this, you will get u3 is equal to 20 minus 10. So that is equal to 10. So here u3 value you will get, that is a 10. Now only one equation remaining, u3 plus v2, u3 we know that is 10 plus v2 is equal to 8, or this v2 become 8 minus 10, that is a minus 2. So here v2 you will get a value of a minus 2. So this is for occupied cell. We have calculated the u1, u2, u3, v1, v2, v3, v4 for occupied cell. Now we have to solve for the unoccupied cell. So for what is for unoccupied cell? For that we require these values. So I will this copy, just a minute. Okay. Now Next is we want to solve for the unoccupied cells. Unoccupied cell, so there is a relation. Now here we want to solve. Second is for unoccupied cell, means where there is a no allocation is there. So for that relation is Cij minus Ui minus Vj. So this is a relation for unoccupied cell. So I will copy this matrix here and I will use only for unoccupied cells there. So this is our matrix and we have calculated value. I will write here. So u1 we have calculated 0, then u2 is a 50, then u3 that is a 10. Similarly v1 is 19, then v2 that is minus 2, v3 minus 10, and v4 is a plus 10. Now we know this value we have calculated in the previous step. Now we are using for a unoccupied cells. So I will remove from this matrix occupied cells here. I will remove. So where there is allocation, I will remove that cells here. Okay, and the remaining is, now we are remaining, these are the unoccupied cell. Now we know for unoccupied cell this is the relationship. So I will write first which are the unoccupied cells. So u1, so here you can see u1 v2 is an unoccupied cell. So here you can check u1 v2. Similarly u1 v3, so that is also unoccupied cell. So I will write first unoccupied cell here. So first is u1 v1, use another color. Okay, then u1, sorry, first is a u1 v2, then u1 v3, then u2 v1, then u2 v2, then u3 v1, and last is u3 v3. So these are the unoccupied cells. Now we are having a relation. We know relation is Cij minus Ui minus Vj. So Cij means cost. So u1 v2, so here 30 is a cost. So 30 minus Ui value means this u1 value is 0, minus Vj, so here Vj value is minus 2, so minus 2 here. Then u1 v3, for u1 v3 means this 50 location, so the relation is here this 50 minus, now here u1 value is 0 for this row, and here v3 means column value is minus 10, so I will write minus 10. Similarly u2 v1, the cost is 70, u1 value is 50, so here 70 minus 50, then here v value is 19, so minus 19. Similarly u2 and v2, the cost is 30 minus 50 minus here minus 2. Similarly here for u3 and v1, so cost is 40 minus 10 minus 19, and last here 70 minus 10, u value is 10, and v3 is minus 10, minus of minus 10, so this will become plus. So our relation becomes, so 30 minus minus become plus, so this value become here 32. If you solve, then here it become plus, so it will be 60, then 70 minus 50 minus 19, so that will become 1, then this will become minus 18, then here it is a 11, and it last it is a 70 plus minus 10, it will remaining as it is 70. So this is a improvement index, we can say this is a improvement index. Now by the procedure, if all the values in improvement index, these all the values in improvement index are positive, so these are positive, only one value is negative, so this is minus 18. So if all the values are positive, then previous IBFS means we have calculated this 779 आंसर is optimum answer, means इससे नीचे हम वैल्यू कम नहीं कर सकते, ट्रांसपोर्टेशन कॉस्ट इससे नीचे नहीं आ सकती if all the values in improvement index are positive. But if there is any value is negative, then there is a chance to reduce the cost. Now here u2 v2 location there is a negative value, so there is a chance to get the reduce the value, we can say reduce the value. So here u2 v2 location there is a chance to reduce the value, so we will solve for that. How to solve that? I will use this, just a minute. So this is our matrix. Now here we are having a chance of at u2 v2. So here minus 18 is there. So means what? Here u1 u2 u3 we are having. Now column number is v1 v2 v3 and v4. So u2 v2 means here u2 v2. So at this location, there is a chance of allocation. So this minus sign indicates that if you give the allocation at this location, u2 v2 location, then your answer may be reduced, or your transportation cost may reduce from 779 to the sum value. So this we have given the allocation here plus sign. So we want to give the allocation here. Now if you check, there are number of allocations are becoming 7. So there may be the degeneracy. So for that you have to reduce any one of allocation. Means what? यहाँ प्लस साइन जो दिया है, यहाँ पे एक दूसरा असाइनमेंट आएगा, अलोकेशन आएगा फ्रॉम दिस 5 2 7 2 और 8 2, इसमें से कोई एक अलोकेशन यहाँ पे आना चाहिए और वहां से वो खत्म हो जाएगा. सो फॉर दैट देयर इज अ कंडीशन, वी आर क्रिएटिंग अ लूप. So for that we are creating a loop like, so it starts from, we are creating loop, it starts from this value and it starts from this point, and it creating a loop means at each corner there may be the allocation. So here I am creating a loop. So here at this end there is allocation. Now I am creating loop from this side. So here this is a loop where at each corner there is a allocation. So we have given the plus sign here. So their loop may be the like this rectangle loop, or there may be the stepping stone. So like this means at each point where there is angle change, there must be the allocation, or you can use like this also, you can get the loop like this also. So for where there is angle change, so there must be the allocation. So in this case we have created a loop where there is a allocation at each angle. Now here I have given the plus sign here. So alternately negative sign I will give here plus sign and here negative sign. So here plus means we have to add the allocation here. Now here from negative sign or minus sign is there, we are selecting the smallest allocation. So here there is a negative sign here and here. So allocation is 2 and 8. So from these two allocation we are selecting the minimum allocation. So 2 is the minimum allocation, and we will add this 2 where there is a plus sign, and we will subtract this 2 where there is a minus sign. So I am adding 2 here. So here there are 2 allocations. Now subtracting this 2 from previous allocation, 2 minus 2, so here it will become 0, and here there is a plus sign, so I will add, that is 10 plus 2, and here there is negative sign, so I will remove this 8 minus 2. So here this is a allocation after creating a loop. Now I will use in the next matrix, so I will correct here. So here we are giving the 2 allocations, so we are adding 2. So here we are removing the allocation, so this 2 will go from that point, and again now here 8 minus 2, so here now it will become a 6, and here 10 plus 2, so these allocations now become a 12. Okay, so after creating loop we have changed the allocations. Means what? Where we have got the negative sign means u2 v2 location. So here u2 v2 location, at this location there must be the allocation. So we have given the allocation here, but at the same time any one of allocation may be removed. So that's why we have created a loop. So at the loop at each corner there may be the allocation. So we have created a loop and given the sign alternative plus minus, and from the minus sign where there is a minimum allocation, we have selected that here in the case 2, and we have added where there is a plus sign, and we have subtracted where there is a negative sign. So you can create a loop like this. It is a rectangle or it is in a stepping stone manner. Okay, so these are the allocation. Now for these allocation we will create initial basic feasible solution 2, and for that here 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 6 plus 20 into 12. So these are the allocation, and if you solve this you will get here 743. So this is initial basic feasible solution 2. So now your previous initial basic feasible solution 1, where we are having the 779 rupees is a transportation cost, but after the optimality test, or we can say UV method or modified distribution method, we have reduced this value up to the 743. Okay, so this is a answer, initial basic feasible solution. Now again we will check for optimality. Again we will check for optimality. So checking for optimality means what? Again we are giving the name u1, u2, u3. Here v1, v2, v3 and v4, and again we are calculating for first for occupied cell. So relation is ui plus vj is equal to cij. In the same way, so here in the same way I will write here. So relation is first is u1 plus v1 and the cost is, so here for this location u1 plus v1 is equal to 19. Similarly u1 plus v4 is equal to 10. Similarly I will write here u2 plus v2 is equal to 30, then u2 plus v3 is equal to 40, and u3 plus v2 is equal to 8, u3 plus v4 is equal to 20. So for these occupied cells we have calculated, and initially we can assume that u1 is equal to 0. Initially you can assume u1 is equal to 0, or you can assume any value equal to 0. So here I am assuming, suppose u1 is equal to 0, that time 0 plus v1, that is becoming v1 is equal to 19. Okay, so again here v1, your v1 become 19. Similarly by the same way you can solve this value and you will get the other values also. So here initially u1 is assumed 0, then you will get the here v4 you will get a 10. Okay, because u1 is equal to 0, so here v4 you will get a 10. Similarly you will get u2 is equal to 32, then u3 is equal to 10, v2 is equal to minus 2, and v3 is equal to 8. So here we have solved this is for occupied cell. By the same way you can solve for the unoccupied cell. So where for unoccupied cell, so there is a relation Cij minus ui minus vj. So here in this case the unoccupied cells are this 30, 50, 70, 60, 40 and 70. So I will directly write these unoccupied cell. Unoccupied cell, we want to check for unoccupied cell. So for unoccupied cell u1 v2 u1 v3. So unoccupied cell u1 v2 u1 v3, then u2 v1 u2 v4 u3 v1 and u3 v3. Similar relation is Cij minus ui minus vj, Cij minus ui minus vj. So Cij, that is a cost, so that is 30 minus 0 minus minus 2. I will write directly the answer, so you can solve 50 minus 0 minus 8, then 70 minus 32 minus 90, then here 60 minus 32 minus 10, then 40 minus 10 minus 19, and u3 v3, the cost is 70, u value is 10 and v value is 8. And after solving this we will get the answer. First is 32, then 42, then 19, then 18, 11 and 52. So this column is nothing but the improvement index, and we know that if all the values in improvement index are positive, then answer is an optimum answer. Then previous IBFS, initial basic feasible solution, is optimum. So previous IBFS is IBFS 2, initial basic feasible solution 2, and that value is 743. So that is optimum answer. Means what? इससे नीचे हम cost कम नहीं कर सकते because we got all the positive values here. So this is checking for the optimality, and this is modified distribution method, or we can say UV method. Okay, so thank you.